Here's our working model of a centrifugal pump, and what we have is a small hobby motor attached to a flexible piece of insulation or rubber tubing, a PVC pipe which is capped with a small piece of clear plastic, and the shaft goes to an impeller that's made out of foam which rests on a plastic block or a painted block, and attached to that is a simple tube. So I'm going to insert this into the water, and I'm going to put a little rock on there because this material is still floating material, and attach a couple of DC connections. Again, there's no shock hazard if we keep the voltage low, and this one we have just 3 volts to test. And so if I test with 3 volts, you can see we have a little bit of flow. I'm going to move it so we can get it into the cup here. That's for 3 volts. Now what we can do with this system, which is easily made just with a glue gun and a couple of simple materials and simple tools, is increase the voltage. And what we can notice in the increased voltage is I have a higher head on this water. We can measure not only the height of the water, but the volume of the water, and you can figure out how much total potential energy is made and created by this. If you're very clever and you add another battery, we better move our container because I know this goes higher, we can get a higher head. So we can compare how much work the motor centrifugal pump does by additional energy. By adding a meter into the circuit, and where we can measure the actual current drawn and the voltage applied, you can measure the time and so forth and figure out how much total energy is consumed by the system, and then using dimensional analysis determine the efficiency of the system by comparing energy in versus energy out.